Okay, so we're going to do question 10.7. Suppose that a firm requires an input bundle of labor and capital with the production function given by B equal to 20L power half and K power half. So part A asking you to show that if the use of labor doubles while the use of capital remains constant, output will increase by a factor of square root of 2. Okay, so it's pretty straightforward. So we just have to double the amount of labor and the amount of capital remain the same. And we want to see how is that going to change the amount of output B. Okay, so we are given B equal to 20 L to the power half and K to the power half. Okay. Now, so if we got L dash, which is equal to 2L, so we got double the amount of L. And K dash is going to be equal to K because K remain constant. Then we want to see B dash, which is the new amount of output. How is that going to be affected? Okay, so the new production function, so the new output is going to be equal to 20, 2L, everything to the power half, and K remain the same to the power half. Okay. So do it step by step. Then B dash, which is B equal to 20 L dash to the power half and K dash to the power half. Okay, and we know that L dash is just equal to 2L power half and K dash is just going to be equal to K. So therefore, if I expand this, I will get 20 times 2 to the power half, which is square root of 2, L to the power half, and K to the power half. So as you can see, 20 times L half, K half is just going to be equal to B. And so therefore, we got square root of 2 times B. So the new output is just going to be equal to the original output multiplied by square root of 2. So that is what the question asking you to show. The output is increasing by a factor of square root of 2. Okay, so part B asking you to show that if the use of capital double while the use of labor remain the same, output again increases by a factor of square root of 2. Again, it's straightforward. So I got L dash, this K equal to L. However, K dash is now, so I say L double dash, okay? And K double dash is now become 2K. And I want to see how is that going to affect output B. So I call it B double dash, which is equal to 20 L double dash power half and K double dash to the power half, okay? And so I got 20 L double dash is just equal to L and K double dash is 2K, everything to the power half, okay? And so if I expand everything, I will get 20 L power half, K power half, and 2 power half, which is square root of 2, okay? And this thing over here, I know that it just be equal to B. So that is B multiplied by the square root of 2. So the new output is increasing by a factor of square root of 2 compared to the original output B. Okay, so part C, use partial differentiation, find the marginal products of labor and capital. Okay, so marginal product of labor is basically the extra output that one extra labor can produce. So that it's just going to be the differential of the production function B with respect to labor. Okay, so we want to see if we're increasing labor by 1 unit, how is that going to affect our output? And the extra amount of output that we receive from an extra unit of labor or extra worker is called a marginal product of labor. Okay, so if I differentiate the production function with respect to L, I'll be treating K as constant. All right, and so therefore it's going to be equal to 20. And so I differentiate L to the power half. That will just give me half. L to the power negative half. And because I'm treating K as constant, so K to the power half will remain there just as a constant. Okay, so 20 times half is 10 L to the power negative half, K to the power half. It's very similar for marginal product of capital, where I differentiate the production function B with respect to capital. And so I'm treating L as constant. So I got 20 as a constant. 20 is a constant, which is remain the same. L to the power half being treated as constant, so therefore it's remain the same. And I differentiate K to the power half, I get half times K to the power negative half. Okay, again, 20 times half is 10 L half K to the power negative half. All right. So part D, asking you to confirm that marginal product of labor is a decreasing function of labor, but in an increasing function of capital. Okay, so this is my marginal product of labor function. Okay, so I got marginal product of labor is equal to 10 K power half, and if I move L to the denominator to get rid of the negative sign. So simplify this, I get K on L, everything to a power half. Okay. Now, as you can see, it's obvious to see that whenever K is increasing, MPL is increasing, and whenever L is increasing, MPL is decreasing because L is on the denominator. Okay, so therefore it's obvious to see that when K is increasing, marginal product of labor is increasing, so therefore MPL is an increasing function of K. Okay, and because L is on a denominator, so whenever L is bigger, the ratio K on L is going to become smaller, and so therefore marginal product of labor is going to be smaller. Okay, so therefore we conclude that marginal product of labor is a decreasing function of L. Okay, now another way to confirm this is to differentiate the marginal product of labor with respect to K and prove that it is positive. Now, if this thing is positive, then we're saying that marginal product of labor is an increasing function of K, because whenever K, so if the change in marginal product of labor given the change in K is positive, mean they are moving in the same direction. Okay, if K is increasing, marginal product of labor is increasing, and vice versa. So if I differentiate the marginal product of labor over here, okay, with respect to K, now easiest way is to keep it in this form when you differentiate. Okay, so if I differentiate with respect to K, I'm treating L as constant. So 10 L to the negative 0.5 remain the same. Okay, and if I differentiate with respect to K, I get 0.5 K to the power negative 0.5. Okay, so therefore, so 10 times 0.5 will give me 5. And I want to get rid of all of the negative signs, so therefore I move L and K to the denominator, so that becomes L half, K half. Okay, so that is just 5 on L times K, everything square root, which is power half. Okay, so square root of L times K. Now, as you can see, this is definitely positive. Okay, L and K are positive. Square root of those is going to be positive, and 5 divided by that is going to be positive. Okay, so if this differential is positive, then we conclude that marginal product of labor is an increasing function of K. Okay, or increasing in K. All right, and again, very similar. If we differentiate L, marginal product of labor with respect to L. Okay. Now, if we want to prove that it is a decreasing function of L, we just have to show that this differential is smaller than 0. Okay. So if I differentiate this thing over here, okay, which is marginal product of labor with respect to L. Again, I'm treating K as constant, so I get 10 L to the power negative half. If I differentiate that, I get negative half. L negative half minus 1 times K to the power half remain the same. So 10 times negative 5, negative 0.5 is negative 5. L to the power negative 1.5 and K to the power 0.5. So I want to get rid of a negative sign, so I get negative 5 K power half divided by L power 1 on 5. So as you can see, K and L are positive, so therefore this ratio is positive. However, we have a negative sign in front, so this becomes negative. Okay, and if that is negative, then we conclude that marginal product of labor is decreasing function of L or decreasing in L. Okay, so that is the second way of doing it. So either by just looking at this because it's quite obvious. However, if you are ever having some more complicated function where it's not possible to tell straight away from just looking at the ratio, then you will just have to do the derivative. Okay, you just have to differentiate and to show that whether it's positive or negative. Okay, and we also want to confirm that marginal product of capital is a decreasing function of capital, but an increasing function of labor. So it's very straightforward and it's very similar. So we got marginal product of capital is 10L 0.5 K point negative 5. So that is 10L on K, everything to the power 0.5. And obviously, again, as you can see, L is on the numerator. So therefore, whenever L is increasing, marginal product of capital is increasing. And so therefore, we conclude that marginal product of capital is an increasing function of L. And whenever K is increasing, because it is on the denominator, it will reduce the ratio and make the marginal product of capital smaller. Okay? So therefore, we say that marginal product of capital is a decreasing function of K. All right, so part A, asking you, suppose that both the capital and labor uses double. What is the effect on the firm's output and on the marginal products of labor and capital? Okay, so if we assume that we got labor, say star equal to 3 labor, sorry, double, so that becomes 2L, and K star equal to 2K. Okay, how's that going to affect our output? So B star is going to be equal to 20 L star to a power half, K star to a power half. Okay, so that is 20 L star is 2L power half, K star is 2K power half. And so therefore, we got 20 times 2 power half, L power half, 2 power half, K power half. So what I'm left with is 20. So if I simplify this, I get 20 L half, K half, 2 power half times 2 power half is going to be 2 power 1, which is 2. And as you can see, this thing over here is just the original B, original output, okay? So therefore, the new output is going to be equal to 2 times of the original output if you double both the labor and capital. So basically, we're increasing labor and capital by a factor of 2, and the output is also increasing by a factor of 2. Now, if that's the case, then we say that we have a constant return to scale. Okay? And we want to see how is that going to affect our marginal product of labor and capital. Okay, so our marginal product of labor is $10K on L to a power half. Okay, so therefore, marginal product of labor star, I would say, equal to 10K star divided by L star. Okay, now K star is 2K, L star is 2L, everything to power half. As you can see, the 2 cancel out, so we are left with 10 K on L to the power half, which is just exactly the same as the original marginal product of labor. Okay, so if we are increasing both capital and labor by the same proportion, the marginal product of labor doesn't change. It remains the same. Okay, so so I would say marginal product of labor remains the same. And how about marginal product of capital? So marginal product of capital star equal to 10, L star on K star, everything power half. Okay, and again, L star is 2L, K star is 2K, and the 2 cancel out, so I'm left with just L on K power half, and that is just exactly the original marginal product of capital. Okay, so again, we can see that marginal product of capital remains the same when you are doubling the both of the input. Okay.